And welcome to another live stream of the Dongfang Hour. I'm Jean Deville. I'm the host of this YouTube channel, which focuses on the Chinese space sector. And today we're together to witness the launch of the third and final module of the Chinese space station called Mengtian. So just before we get started, just want to say hello to everybody in the chat. It's nice to see that there are already over 200 people that are currently watching. Hope everyone is doing fine. Do leave me a message in the chat just to make sure that the sound is okay. Can you guys hear me okay? And just, also mention where you're watching from and, what are your thoughts on today's launch, which should take place roughly in 1 hour and a half, basically. Should take place at 7:35, 37-ish UTC. And so this gives us ample time to, to discuss a lot of interesting details about Mengtian. All right. Volume is a bit low. Let me try and make that better. Is it better now? Let me know. 1 2 1 2. And so audio is nice, just quiet. Sound is fine. Excellent. Great. All right. Hi, Dune Warrior from USA. Apparently it's still a bit soft. I'm going to increase the gain a little bit. Hope that doesn't increase too much noise. And I'll just, should be okay. Hi, NG from Vancouver. Anybody from Europe? I guess it's early morning in Europe, as you can see in the background here of my living room. And so I haven't got much sleep because of this launch, and I got my tea ready just to make sure that I can power through this roughly 2 or maybe even 3 hours of streaming, depending on how long the commentary is on CCTV and other live streams. So the live stream is already on some Chinese media channels, and basically, the platforms have opened on the launch pad, and basically we're still in the fueling process, and that's why we see white fumes that are coming out of the rocket, various points, venting holes of the rockets. Wind is a bit strong. If we look at some of the live, let me see if I can share it. Now you can see that here's a source that I found just now that you can find on Bilibili, and basically you can see from the tree leaves that I think there's roughly 30 kilometers per hour of wind, which is fairly strong, but not unbearable for a rocket. I think scrubs usually happen at a higher velocity, so we should be pretty good. And just going back to this screen. All right, greetings from Malaysia. Hi. Andy watching from Seattle. Cool, very cool, Andy. Hi, Andy. I was in Seattle just a couple of weeks ago. Greetings from Tianjin. Very cool. Thailand, Nigeria. Wow, nice to see that there's really the whole world that's over here. All right, 250. Yes, so let's get started. Just before we get started, a quick plug, because I've had a lot of questions on the t-shirts that I've been wearing in recent episodes. Just a quick plug for our merch store that we just launched over the past week at shop.dongfanghour.com. This is something I'm really excited about because we've been really investing a lot of time over the past months in designing the designs we did. So I'm working with a designer called Ed5. Big shout out to your excellent work, Ed. And we're releasing different series of merch. The first one is on Chinese launch pads. And so there's one for Jiuquan, Taiyuan, Xichang, and Wenchang. And as you'll see, if you go onto the shop.dongfanghour.com, there's a lot of small details in every design that relate to basically the launch site environment, the rockets that are launched. So there's also a full description. So if you're interested, go to shop.dongfanghour.com if you want to pick up some merch. It's something that was pretty important to me, because when you want to get some space merch, it's really easy today to get some NASA, to get some SpaceX themed merch or some Russian space merch. It's much more difficult when you are trying to get Chinese themed space merch outside of China. And so we're trying to remedy that, and also just add some China space swag to space enthusiasts in general and to complete your collection. So hi, Henry from Ghana, ZG, Alpaca from Boston. Excellent. London is here as well. The United Republic of California. All right, guys. So this is how the live stream is going to work. We have roughly 1 hour and a half together before the launch. So feel free to ask any questions in the comment in the chat. I'll try to answer as many questions as I can. I have a couple of things I'd like to discuss before the launch. So I'm going to give some brief context on the Chinese space station. We did a lot of that during the previous stream, so I'll do that rather briefly. Also discuss what the astronauts of the Shenzhou 14 crew have been doing over the past months. A lot of things have been going on. We'll also discuss in detail what the Mengtian Space Lab is all about. I have a 3D module that was made specifically for this episode. And so we'll be using that to explore the outside and the inside, well, mostly the outside of the Mengtian experimental module. We'll discuss also the experimental racks that are inside this module. And if we have time before the launch, we'll discuss a little bit also at the Long March 5B. And also, how Mengtian is going to dock to the Chinese space station. There's a specific process, and why Mengtian is going to do what it's going to do, basically. So lots of stuff to discuss. All right. All right. Let's get started. So quick context on the Chinese space station. So the Chinese space station is something that started construction last year with the launch of the Tianhe core module, but it's something that should be inserted in a larger context over the, it's an effort that dates back to 30 years, basically to 1992, when China kicked off its first crewed spaceflight program called Project 921. And at the time, really, China was starting from scratch. And so in terms of crewed spaceflight, although there were some, there was research being done beforehand, and there was also sort of a failed attempt for a crewed spaceflight program in the early 70s, late 60s. The real program was really Project 921, started in the early 1990s. And so this program was about, the early stages, the first 10 years, the first 20 years of this program was really building the technology, building blocks to enable China to have a permanent space station in low Earth orbit, which is the end goal that we're seeing materializing today. And so that's, for example, building a human-rated rocket. That's the Long March 2F that you can see here with the pointy end, which is the launch escape system that can pull the astronauts to safety if anything goes wrong during the launch. And it's also, for example, the Shenzhou spacecraft that you can see here. This is something that was designed in the 1990s. It was launched for the first time in 1999 at the same time as the Long March 2F, uncrewed. And this is at the time, the Chinese went for a pretty conservative design in the sense that this is something that resembles quite a bit the Soyuz spacecraft that is used by the Russians. So next, they also designed several other important technology building blocks, such as the Tiangong cargo spacecraft that you can see here, because it's important to launch on a regular basis, water and food and fuel to the taikonauts on the Chinese space station. Important to have this. This was launched for the first time in 2017, and 4 have been launched in total since that date. There were also other important building blocks that I haven't really mentioned here, but don't have any pictures, but basically building an indigenous EVA suit, so the Phaetian suit, which enables astronauts to perform spacewalks. And there's things like just understanding how human biology works long-term in space. And so there were 2 experimental space stations called Tiangong 1 and Tiangong 2, very they didn't last very long. They were just temporary space stations, lasted a couple of months. But to understand, how the human body reacts, and also, testing systems like the environment control and life support systems, important things like that. And this brings us, with all this research and development done over the past 30 years, this brings us to the Chinese space station, the permanent station, which is in construction today. So I see a Quest Tech is asking why the escape module is installed. Isn't this an unmanned mission? So yeah, that escape tower is actually for the Long March 2F. So that's not what's being launched today. It's just one of the building blocks that were developed by the Chinese over the past 30 years. It's what launches the taikonauts, the Chinese astronauts today. But today, nowadays, but today the launch that we're seeing is the Mengtian Space Lab. So it's unmanned, and it's being launched on the Long March 5, Long March 5B, which is China's current largest, most powerful rocket to date. Neil Deng is asking, are you in China now for this live stream? Unfortunately, no. It would have been extremely cool to be in China, having another camera that would be filming the launch site in the background. Unfortunately, it's not the case. There are still some, COVID restrictions, which make it a bit complicated to travel at this time. So I'm based in Europe, as you can see, with a dark background right now. It's pretty early in the morning in Europe. It's 7:15 over here. And so, yes, I was saying all those technology building blocks led to this Chinese space station. So what you see here is what the Chinese space station is going to look like once Mengtian is launched and docks with the Chinese space station. And so what is already present here is the central module, the Tianhe core module that was launched last year. It's the module that has the Chinese flag on this picture. You also have Wentian that's installed on the starboard side. So it's that big module that you can see on the right on this picture. And so Mengtian, what is going to be launched today, is the module on the left. And so that's obviously not docked to the Chinese space station at this moment. And the other small spacecraft are either cargo spacecraft or Shenzhou spacecraft. That either bring cargo or bring taikonauts to the Chinese space station. I see Kim Michelle is asking, has propellant loading been completed? So I need to Alt-tab to see the current, the latest situation. Propellant loading is usually done, depending on the propellant, is done until the very last moment or just a couple of minutes before. So we're still 1 hour and 20-ish minutes before the launch, and so no, it's still normally it's still ongoing. And so moving on, I just want to really describe very briefly each module of the Chinese space station briefly before getting to Mengtian. And so you have the central one, as mentioned, the Tianhe core module. And this module is the first one that's launched. It's sort of the command center of the Chinese space station. And so here's an individual artist rendering of this space station. It's pretty independent. It could live its life as an independent mini space station. It's roughly 20 tons in mass. And it has everything you need for it, to just live its own life. You have life support systems, you have sleeping quarters for the taikonauts, you have a kitchen, you have a toilet, you have orbital control systems and attitude control systems. So it's those thrusters that you can see, those little nozzles, black nozzles that you can see here and there, and that can can adapt the orientation of the space station. You have halophilic thrusters for orbital control. You have those big solar arrays that you can see here that produce power and that store power and batteries for the Chinese space station and all its different parts. You have those spherical shapes in the center of the space station, which are control moment gyros. Again, this is for attitude control. You have an antenna next to that. That's obviously for communication with the ground. It goes through a relay satellite. And you have a multi-docking nod for spacecraft to dock with the Tianhe core module, and you have a robotic arm for, multi-purpose robotic arm to help astronauts with EVAs and for other similar things. Okay. Someone's asking what the countdown is. So this is a rough countdown. I need to adapt it by going back to the actual CCTV live stream, but this is roughly when the launch is going to happen. So we have 1 hour and 21 minutes left before the launch normally. R3D Powell asking, is there any experimental rack that the ISS doesn't have? That's an interesting question. So we'll discuss the experimental racks, later in this live stream. Most of them, I think, have equivalents in the ISS. I did not check for every single one of them, but generally you've had equivalents on the ISS. Although maybe the details, the specs are different. I didn't do a one by one comparison. And so the Tianhe core module, here's another picture of it. This was in the test facilities, last year, in the first half of last year. So you can see a lot of details in higher definition here. And so this was launched early 2021. And then the Chinese launched the second module, Wenchang, which is the module that you can see on the right here. And this module is what we call an experimental lab. And this name, experimental lab, means that it's dedicated to space sciences, meaning that, Tianhe, not that much space sciences will be taking on there a little bit, but not that much. Wenchang will be much more dedicated to space sciences. So you have more scientific science racks. Inside, you also have attachment points on the outside to put experiments if you want to expose your experiment to the outer space environment. And it does also, it's worth noting that Wenchang acts as a backup of the Chinese space station Tianhe core module. So you have backup sleeping quarters. You have also a backup kitchen, a backup toilet. You have a backup environment control and life support systems. You also have backup attitude control systems. And so if anything goes wrong on Tianhe, you have Wenchang as a backup. And so this is another high definition view of Wenchang. So this is not what's being launched today. This was what was launched a couple of months ago in July. So for those who are just joining, I'm going really quickly over the other modules of the Chinese space station before getting to Mengtian. Okay. And here's another view of Wenchang. So this is an interesting view because you see those squares in that, central upper module. There are like, 9 squares, and this is areas where you can fix directly, scientific experiments. These are squares that can provide power, that can provide data, and that can also provide thermal control to your experiment. And so there's a lot of things you can do with those. And I think there's roughly 24 attachment points on Wenchang on the outside for scientific experiments. And this brings us to Mengtian. So Mengtian is the module on the left here. Now, before I go into detail on this module, this is Mengtian is what you see on the screen at this very moment. This was Mengtian from, I think this is a picture from 2 weeks ago. One of the first real high definition sort of pictures that we saw of Mengtian, and where you can see a lot of details. I have a 3 model for that. So do stay tuned to the live stream. But before talking in detail about Mengtian, I just also want to describe a little bit what the astronauts have been doing over the past, basically the past couple of months. So the Shenzhou 14 crew arrived on the Chinese space station in June, and they had the very important task to oversee, Wenchang docking, and they've been doing, basically I have a quick presentation for that. Just bear with me. There we go. So just some B-roll. And so so we're in the construction phase of the Chinese space station, which is basically last year and this year. And so during this phase, what the taikonauts are doing on the Chinese space station is basically focusing on making sure that every new subsystem that is delivered to the Chinese space station is working nominally. Everything is, is safe, and everything is unfolding as planned. And so there's less focus on space sciences, although there was quite a bit of stuff that's been done on notably on biology, on botany, which I'll discuss in a bit. But mostly it's on the construction of the Chinese space station. And if we add some B-roll of what the astronauts are doing here, so this is what you see here is the crew that's currently on board the Chinese space station. You see them working, unpacking things that were, cargo that was brought to the space station by the Tianzhou 4 cargo spacecraft. You also see them installing various bits and pieces, the racks, and also various subsystems of the space station. And maybe to sum up some of the things that were done over the past couple of months, I'd say maybe one important thing was that 2 spacewalks were performed, 2 EVAs, extravehicular activities. And in both cases, there was an extended pump system that was installed on the outer walls of the Chinese space station. And the reason for that is that basically there's a lot of thermal control that's necessary for a space station, just because there's, for example, variable exposure to solar radiation. And so there's hot areas and cold areas, and you need to balance that with a thermal control system. And you also have a lot of electronics that are running inside the space station. You have the subsystems, you also have the experimental racks, and there are definitely quite a few of them in Wenchang and also in Mengtian. And there are also attachment points outside of the space station to fix experiments, and these require power. They also require thermal control, and so these extended pump systems are really there to that were set during the EVAs were really there to enhance thermal control capabilities. Okay, another thing that was interesting and that was done during the past couple of months by the Shenzhou 14 crew was raising the panoramic cameras. And so, the amazing footage that we see of the Chinese space station, like what you're seeing on the screen right now, this is shot from panoramic cameras. You have panoramic cameras on all of the modules of the Chinese space station. If you see them up close, you have basically 4 lenses in all directions, so panoramic view. But these are very close to the space station walls, and they need to be raised to have a better view of the surroundings. And the reason why they need to be raised is because basically when you're launching a space station module, the distance between the payload fairings of Long March 5B is a bit more than 5 meters, and the modules are more than 4 meters, and so you don't really have the flexibility to have systems that are sticking out of the the outside walls of the module. And so these systems that generally they're either raised electronically if you put a mechanical system, and that's the case for the antenna. Usually that's raised once the launch is performed. The antenna is raised, and that's for critical systems, right? You want to be able to control that mechanically. But for, I guess, less important systems like the panoramic cameras, then this is usually raised manually during an EVA. And so this is what was done by the crew of the Shenzhou 14, and this is why we get great views of Wenchang. This is what you can see on the on the bottom left of the this footage that you're seeing. You see 天河全景摄影机. So that's the panoramic camera of Tianhe. You also see that for Wenchang as well. So it's really cool stuff because the footage is really brilliant. There are a lot of angles. They also have nice cameras on the robotic arm, so you can get various angles also of the Chinese space station. So that's pretty cool. All right, so that's what was done during the EVA. Another important thing that was done during the EVA was just testing the airlock of the Wenchang experimental module, because Wenchang basically has an airlock module in its center where spacewalks are performed. It's an enhanced version, a more efficient, a better version of an airlock chamber compared to what was previously used, which was the multi-docking node of the Tianhe core module. And so just performing those EVAs was making sure that the airlock was working fine. Let me see if there are any additional questions. Will there be a further expansion of the Chinese space station? I'll get to that a little bit later. So probably yes, because there are backup modules that are already manufactured on the ground that were supposed to replace Tianhe, for example, if anything went wrong, and you have high-ranking people in the space industry in China that have on a regular basis spoken about a future with 6 modules. So I'm pretty confident that by the end of the decade there would be an expansion, but this is not confirmed. R3D Powell, do you know the inside layer of the space station? Yeah, we're going to explain that with the 3D model in just a bit. All right. So just moving on what's been going on over the past couple of months. Another thing that was very important that was done by the Chinese space station was with the robotic arm. And so let me just show a little bit what I'm talking about. So there are two robotic arms on the Chinese space station. You have a 10-meter long robotic arm that's with the Tianhe core module, and which can lift a massive amount of payload, I believe over 20 tons. It's really multifunctional. It can, carry astronauts. There's a sort of working station that the astronaut can sit on or can stand on at the tip. It has, I believe, 7 degrees of liberty, so it can really move in many directions. And it has cameras, so it can be used also for monitoring purposes. There are a lot of uses for the robotic arm. It can move cargo. I mean, it's also a backup for the transfer of Wenchang and Mengtian when they dock. The transfer to the starboard port side. I'll get to that in a little bit, but so it can also act as a backup. So that's for the main robotic arm. But Wenchang also has its own robotic arm. It's a smaller one that's 5 meters long. So what you're seeing here on the picture is the large robotic arm. Here's another picture of the large robotic arm. That was when it was on the ground, obviously. And you have a smaller robotic arm, which is what we see here on this image. And so same thing, 7 degrees of liberty. So has a lot of flexibility. It's only 5 meters long, and it has less, carrying capabilities. We're talking about less than 3 tons compared to the more than 20 tons of the large robotic arm. But it has one very important advantage, is that it's extremely accurate. And the reason that this arm is needed is that it's this arm that will be manipulating the experiments that are outside of the space station. And so the robotic arm can take, one of the experiments and put them in a specific area or a specific attachment point. Now, one other thing that was very cool, and this is what was actually tested over the past months by the Shenzhou 14, is the interconnection of both arms. And so both arms can interconnect with this adapter that you see here that was installed by the previous crew, the Shenzhou 13 crew, during their first EVA. So they took this system and they installed it outside on the outside walls of the Tianhe core module. And so what this is, this connector, this adapter, is that you have the long robotic arm that grabs the adapter from the top here, the top interface here, and then you have the smaller robotic arm that grabs the bottom, and together they form this super long 15-meter long robotic arm. And I think I have an animation for that. So here's a picture of what looks like when it's interconnected, 15 meters long. And I have a quick animation for that I took from the previous CCTV live stream. That's pretty cool. Just let's see. There we go. Nope, that's not good. Nope, not this one. This one, yep. So as you can see, this is from a CCTV 13 live stream. I thought this animation was pretty good. So you see you have the large robotic arm on the Tianhe core module. So this long robotic arm is, well, first it's going to grab an attachment point here to get closer to the small robotic arm. And this long robotic arm then is going to grab the connector that you see on the, on the bottom left of the Tianhe core module there. So you see it's going to grab it. So animation's a bit slow, bear with me. I'm going to have a sip of tea while we're waiting for that. It grabs the connector and then it goes to look for the small robotic arm. And there we go. We have a 15-meter robotic arm. And this was something that was actually tested by the Shenzhou 14 during the stay of the Shenzhou 14 over the past couple of months. And so what is the point of having this massive 15-meter long robotic arm? Well, as we'll see in a little bit, there are attachment points on the outside of Wenchang, but also of Mengtian, to put experiments, right? And so for Wenchang, naturally, Wenchang has its own robotic arm to manipulate these experiments, but Mengtian, as we'll see once again, doesn't have its own robotic arm. And so very likely it will be using, I guess, so this is personal speculation, but it'll be using the Wenchang robotic arm. But for that, you need an extended robotic arm potentially. And so that's why, both robotic arms combine. So you have the length of the longer robotic arm, but you also have the precision of the smaller robotic arm. And so you have these advantages that are combined. And so also Mengtian can benefit from having a robotic arm without, being launched with its own robotic arm. And there are advantages to that, really, because, when you're launching a robotic arm, the robotic arm is stored on the outside of the space station, right? Outside walls. But when you want to fit, you have to make everything fit within 4-ish meters, because you're putting this module in a rocket payload fairing, the Long March 5B. And so if you're putting a big chunk of metals, the robotic arm, on the outside wall, then your own module has to shrink to make space for that robotic arm. And so that's why it makes sense to just have one robotic arm on Wenchang that's used for Mengtian as well. And so this way we'll see in a little bit that the diameter of Mengtian, all Mengtian compartments are pretty large and consistent, more than Wenchang. So I just saw Larry Ng's generous support. Thank you so much for your support. It's really appreciated and really helpful for the channel. Thank you so much. All right, then. So that's for the robotic arm. Let's move on to the next point I want to talk about, which is biology experiments. Unless there are any questions on the robotic arm. Latest questions. How is the current wind shear? There's a typhoon nearby. Yes, there is a typhoon nearby, actually. Hainan. It's not on Hainan at all at the moment, but the outskirts of a typhoon, you still have high winds. Let me just check out, before continuing the presentation, what's the current situation. So just bear with me for a bit, and I'll just put some cool footage of the robotic arm as you guys just wait a minute as I see how things are going. Hopefully nothing's going to get scrubbed. So I see that the CCTV live stream has begun. Anything on... wait a second. So just checking the weather for you guys, if everything is going as planned. Because if the wind continues to increase, it's possible that we get a scrub. But so yeah, here you can see. I just want to show this really briefly. You have an animation by Twitter account Sugar U of. Let me just show that for a little bit. What we're seeing here is the typhoon that's in the vicinity of Hainan. So Hainan Island is what you can see. It's the island that's just on the upper left of the typhoon. And so this image was this was uploaded 1 hour ago. Let me see if I can make this bigger. And so, yeah, that's what's creating the wind. But at this point, I mean, we're still on the outside of the typhoon. So let me see if I can get the values of the wind, and then I'll get back to the presentation. Just bear with me. Okay, so I have the data here we're talking about. So it's 25 degrees currently. Fueling is still going on as planned. So okay, I don't have the wind data, but as soon as I have it, I'll communicate it to you guys, and I'll let you know. Michael Tan is asking, how do we support you? So you can support me by long-term by going on Patreon, patreon.com/dongfanghour. There's a link in the description. Or if you want to do this one time, well, there's super thanks, super chat on YouTube, or there's buymeacoffee.com/dongfanghour, where you can just buy me a coffee or as many coffees as you like. It's really helpful for the channel. You don't have to do it. It's still strongly appreciated. Thank you so much for anyone supporting the channel. All right, guys, I want to talk about some experiments. So I mentioned just now that there wasn't that much science going on in the Chinese space station for now, because a lot of the time of the Shenzhou 14 crew was focused on the construction of the Chinese space station. It still is. But there was one module that was used quite a bit. So let me just show you the modules that are currently on the Chinese space station at this very moment, taking off this B-roll. And if we, so these, okay, I'm going to hide my camera. I'm hiding a little bit. There you go. So these are the modules, the scientific experimental racks that are on the Tianhe core module on the top, and then you have the Wentian module at the bottom. And so there's one at the bottom that's the Life Sciences and Ecosystem rack. And this one is a very interesting rack because it's basically a rack where you're going to grow plants. You're going to, have some small animals like fish potentially to see how microgravity affects them. And so what we're seeing here is a view of that central module inside the experimental rack. And this is where you would be growing typically, some plants. It's pretty sophisticated stuff. So you have cameras to monitor what's going on. You have temperature control. You have humidity control. You have also, you can control the lights, the tint of the light, the intensity of the light, if you want a blue tint, if you want a red tint. So all this is naturally controlled. And the idea behind this is to see what is the effect of being in space in microgravity on plants, on the pollination, on basically when you grow a plant, okay, maybe it grows, but when it produces seeds, how are those seeds affected? If you replant those seeds and you continue this cycle from cycle to cycle in microgravity, do the seeds lose in quality over time? That's definitely an important question, especially if we're all going to explore, if we're going to do deep space exploration or explore the moon. It won't be as easy to send food from Earth. I mean, for low Earth orbit, for a Chinese space station, you have Tianzhou, the cargo spacecraft doing that. But for the moon, typically it'll be much more difficult. And so it's really studying things to make growing plants in space something that's sustainable. And so it's also studying the type of soil that's being used. Studying the type of soil that's being used, and how microgravity affects the soil, what's the ideal type of soil, things like that. You have another image here, which is of a fish tank. So this is not taken on the Chinese space station. This is taken on the ground because the Chinese, CAS, CMSA, they have, so Chinese Academy of Sciences, they have the same modules in the space station, but on the ground. And the idea is to reproduce the space station experiments on the ground so we can really compare the results in microgravity and in a normal gravity environment. And so this is what you're seeing on this picture here. And so typically the fish tank is also to study how microgravity affects microorganisms and also small animals, so typically fish. Because it can affect, it typically affects humans for bone density, for example, bone density loss, muscles, also blood circulation, a lot of things. And so it's interesting to watch this on, on fish and on other small animals as well. And so that's for the biology experiments and the botany experiments. I just want to note that there was a question just now on if there was an equivalent for each module on the CSS, but on the ISS. And for this one, typically, space botany, space biology is something that's been studied for many, many years by all spacefaring nations. You have, for example, on the ISS right now, I think you have the Advanced Plant Habitat, which does exactly this. You have also the Russians studied this quite a bit in their Salyut space stations, I believe. And so definitely it's for a long time been a focus of space sciences. And so this is one thing that's been done by the Shenzhou 14 astronauts. They've been, they've been planting notably in the Wentian Space Lab. They've been planting rice. They've been planting thale cress flowers, which are naturally plants that are well understood. And so monitoring how they grow. The astronauts also take small extracts of the plants as it grows, and they have a cryogenic storage compartment in the Mengtian Space Station. And so they put those extracts in the cryogenic storage, and these extracts are then samples are brought back to the Earth when the Shenzhou crew return to the Earth. There's always some area in the Shenzhou spacecraft that's dedicated to bringing cargo back on Earth. Today, China does not have a dedicated cargo spacecraft that can return to Earth And so cargo that's being returned to Earth necessarily has to go through Shenzhou, which is a disadvantage because you can't put that much cargo on Shenzhou. But this is something we know that the Chinese are working on to have a reusable cargo spacecraft that can naturally bring cargo back from the space station. So Tianzhou, it deorbits and, it's destroyed during the atmospheric reentry. There's, it's interesting to have that happen actually, because you can dispose of waste, as we'll see in a little bit. So that's for bringing back samples. You also have, I believe the Shenzhou 14 crew also, they grew some lettuce. So it wasn't in the wreck, it was outside of the wreck, and that was just for consumption by the astronauts, is my understanding. Space biology, space botany going on and going strong in Wentian. The other modules, I haven't seen that much news of them being used. They've definitely been checked by the astronauts, but haven't seen any high-profile results that have been published at this moment. All right, so I got questions again on the wind, so let me just have a look if I can get the value. Or is there anything worrying at the moment? Well, I don't know. I'm seeing the CCTV, the Yang Shi Xinwen, the CCTV live stream going on as planned. So I don't think anything is wrong. If you guys want to have a look at what I'm looking at, this is what it looks like. And you can see that sort of the grass in the background, the vegetation is moving a little bit, but nothing too bad in my opinion. You can see in the rocket in the back, it's still connected. You have the swing arms that are still holding the rocket together. And you also have, those black umbilicals that are connected to the fairing. That's the air conditioning. Things aren't looking too bad in my opinion. I'll try to get the value of the wind and to get back to you guys. I don't know the exact value really of when it's when a launch is scrubbed. I know that just now there was a wind of 30 kilometers per hour. The rough idea I have of a scrub is maybe 50 kilometers per hour, but not exactly sure. So if any viewers have some more background on wind velocity and scrubbing a launch, feel free to post that in the chat, in the comment section. Okay, so let's move back to the presentation. I want to see if there's maybe any more questions before that. Gang Kai Hawk says the wind looks like it's getting stronger, though. Yes, I believe, if the typhoon is getting closer. Pearson Leak says the prediction is November 3 to 4 for strong wind. And so, yes, so we're not exactly at that time, still a couple of days. Do you know what, so ZG Alpaca is asking, do you know what radiators the CSS use? Unfortunately, I don't know that level of detail. I know there are 3 separate thermal control systems, but I don't know the exact radiators. There's a Liangmi that has supported me with $1.99. Thank you so much for your support. That will buy me some additional coffee and tea to keep me going for Dongfang Hour. All right, guys, one last thing I want to talk about on what the astronauts of the Shenzhou 14 have been doing over the past couple of months. And this is, it's installing the last module of the Environment Control and Life Support System. I just want to spend some time explaining what this is, because I think this is a really, really cool module. And so let me just bear with me. I want to share my screen. This is what it looks like. I want to open this with a separate browser so you guys can see what I'm doing with my mouse. Just 1 second. There we go. Okay, let me see if I can open this. There we go. Okay, so now normally you should be able to see my screen. Do you see my mouse? Just cursor capture is on. Just want to check that everything is working as planned. Okay, So now you should be seeing my mouse. Okay, excellent. So what is the Environment Control and Life Support System? And so it's what enables astronauts to survive on the space station, right? Because astronauts, they need to breathe. Astronauts need to drink water. They need to go to the toilet. Obviously, there are things like that. And the gases, the percentage of oxygen needs to be correct in the space station, things like that. And this needs to work in a sustainable way because you're not going to just continuously send water and oxygen to the space station, right? And so this is what the ECLSS is for. So here you have a diagram that I translated into English. And what the astronauts of Shenzhou 14 installed was the item that I have I've added a red border to this. So the CO2 recycling subsystem. But before getting to that, just how does this thing work? So let's look at this diagram. So astronauts, they breathe in oxygen. So it's the O2 that you see here. They drink water naturally, and they release vapor and sweat. So vapor notably when they are speaking and breathing. They release CO2, carbon dioxide, and they also release, naturally they go to the toilet, and so you have the toilet flush. And so to recycle all this, basically, first of all, if we look at the toilet flush, this is sent to the human excrement storage section, and then there's a urine treatment system which takes all of that and sort of separates and extracts water from it and then releases the remaining waste. And so the remaining waste that can't be recycled, this is generally the solid waste, and you also have some very salty fluid residue that cannot be recycled. And so that is, they get rid of this residue. Now, what's important to note here is that this is not just thrown into outer space. This goes to a storage area, and this is then put on a Tianzhou spacecraft when a Tianzhou undocks and deorbits and performs an atmospheric reentry, which is destructive. So as it's destroyed, might as well put the waste that cannot be recycled in there so that it's destroyed in the process. Okay. There's so this water that's extracted from the human waste is then sent to the water treatment subsystem that you can see up here. And so this really, it's a very important module that cleans up the water. And so once this is cleaned, you have recycled clean water that goes to the water management system that distributes the water then to the astronauts, either for consumption, either for cleaning, and for other uses. Okay. And now if we talk about oxygen, this is really interesting because the Tianzhou cargo spacecraft sends oxygen on a regular basis to the Chinese space station, but it cannot, but it does not send oxygen. That would be extremely complicated because you'd have to store it in a liquid state to make, for it to have some acceptable density, but then, liquid oxygen is liquid at a very cold temperature. So we're talking about cryogenic system, probably way too complicated. And so the solution that was chosen here, which is pretty common, I believe, is to perform the electrolysis of water. And so you take water, you perform electrolysis, and so basically you're splitting water into two subcomponents. You have hydrogen and you have oxygen. So oxygen is re-injected into the space station for astronauts to breathe, and the hydrogen byproduct, it's basically, it's tossed overboard. It was tossed overboard because it wasn't really useful. But this is where what the astronauts, the system that they installed over the past month, I think it was in June or July, this CO2 recycling subsystem, this changes everything because you can take the hydrogen and you can take also the carbon dioxide that's released by the astronauts, you combine them, and this produces basically water. There's a reaction called the Sabatier reaction, which produces water which is re-injected into the water treatment system. And you also have a byproduct that's methane that's not useful in this situation. And so that is, released as a harmful gas that is not needed. Okay. And so this is how things work, how things are made sustainable in the Chinese space station, which enable the Chinese to replenish the, basically water on the space station every 6 months. I think a previous figure that I had read was that before the astronauts installed this system, the reuse of water, the recycling rate of water was around 80%, but with this system, it reaches 90%, which is also, I think, the value on the ISS, although I would have to check. So we're talking about similar values now. And that's for water, that's for oxygen. Now, it's worth noting that for food, this is not something that's a sustainable resource or a reusable resource. On the space station, food is sent up by a Tianzhou cargo spacecraft, and so I think that's the whole point of the botany experiments, right? To be able to learn how to grow plants sustainably, grow food sustainably in a microgravity environment, to rely less and less on a cargo resupply. And I know that some of the research directions of the Chinese scientists that are making the ECLSS at this moment is to improve the urine treatment system, to try and extract even more water from this waste that's discarded, to make sure that we're not losing any water there. Although I believe there are diminishing returns there because naturally, most of the water is already extracted from that part. And so let me just go back to, whoops, that's not what I wanted to do. Just bear with me for a while. There we go. And so that's what I wanted to cover on the what was going on in the Chinese space station over the past couple of months. Now, let's focus on. I want to focus now more on the Mengtian experimental module. So, what is the Mengtian experimental module? What capabilities will it bring to the Chinese space station? Basically, if I have a 3D module that was made here, so just let's see if I can show that at this moment. Okay, how do I hide this? Sorry, guys. There we go. So what you're seeing here is the Mengtian experimental module that was made on SketchUp. And so we've been doing this with a designer. I've been working with him, and so it's not necessarily 100% accurate because basically we've been taking images that were available at the time of Mengtian. There weren't that many. They were low definition, and so some details may not be entirely accurate, but it's definitely something that's sufficiently accurate for the purpose of this presentation. And so the Mengtian experimental module can be subdivided into 3 sections. You have the main section here, that's the working compartment, and this is what will dock with the Chinese space station. So you have the docking port that's here. Normally you have an indexing arm that I'll speak about a little bit later that helps the astronaut move to one of the side docking ports or berthing ports. And it's in these, it's in these it's in this working module that all the experimental racks will be. And so this is a section that's dedicated to space sciences. The advantage that Mengtian has over Wenchang in terms of space sciences is that Mengtian doesn't have the role of a backup of the Chinese space station, of the Tianhe core module, but Wenchang has. And so Mengtian doesn't need to have sleeping quarters. It doesn't need to have a toilet, doesn't need to have a kitchen, doesn't need to have all the backup systems that Wenchang has to back up Tianhe, which means that it can really dedicate more space to space sciences. And this is probably why this working station has more experimental racks than Wenchang, where I think we're talking about there are 12 experimental racks-ish that are in here that are launched with Mengtian, as opposed to there were 4 with Wenchang. Okay, so this is what this module here looks like. You also have the resources module, the Ziyuancang, that is here. That's at the end. And so this is exactly the same as on Wenchang. So what you have here is, so naturally you have the massive solar arrays that have a length of 55 meters. And these produce, I believe I read, 36 kilowatts of power. And they're pretty, newest generation solar arrays. I think this is where you see that China has the latecomer advantage. They're able to put the latest solar array tech compared to the ISS, which was probably cutting edge technology when it was sent into space. But the solar, typically where you see a gap in technology between the ISS and the CSS is for these technologies that have really improved a lot over the past 2 decades. And so the efficiency, notably, of these solar arrays and the weight is significantly higher for the Chinese space station. We're talking about an efficiency, I think, of 30%. These entire solar arrays, I think one on one side weighs 1.2 tons. And the solar panels here, they're actually really thin. It's a film. It has a thickness of 0.7 millimeters. And when you watch videos from a panoramic camera on the Chinese space station, you can see that these, it's really a film. It really wobbles a little bit when it's being deployed, for example. So that's what makes them so light. Probably makes them a little bit more fragile. It'll be interesting to see how that ages with time. Okay, naturally, in the resources module, you have propellant, I think 1.5 to 2 tons of propellant, notably for reaction control systems to control the attitude and for orbital control. You have an antenna that's here for communication with the Tianlian relay satellites. Basically, the way the Chinese space station communicates with the ground is not directly with ground stations, because you'd only get communications when the CSS is flying over China. And so what it does is that it communicates with relay satellites that are in geostationary orbit. Basically, you just need 4 geostationary satellites, 3 or 4, I forgot, to have a full coverage of the planet. So it sends the signal to the relay satellite, and then it's sent back to the ground. And so just want to say a special thanks to the support I've been getting. Chris Quoth, thank you so much for your support. Coming from Australia, I think. KCH Lee from Hong Kong, I would guess. Thank you so much, as well as Jay Wong. Yeah, thank you very much for your support, guys. I really appreciate it. And now the most interesting module of the Chinese space station, guys, for me, is this central module. And this central module, this compartment, is actually a dual module in the sense that you have what you're seeing on the outside, which is the unpressurized cargo compartment, but you also have what's in here, which is the smaller module here, which is an airlock chamber basically, and that is basically the payload compartment. And so, why is there this module? Why is there this compartment? The idea is that today, if you want to transfer an experiment to the outside of the space station to attach it to one of the attachment points, typically what you see here, these squares, these are attachment points where you can put experiments on top. So these attachment points, they provide power, they provide data, they provide thermal control. If you want to use these attachment points and put your experiment on there, you probably have to perform a spacewalk, an extravehicular activity, which is costly, which takes time, which also has some risk. There's never zero risk, and so what all this is. And so what this compartment does is it enables astronauts to send payloads to outside of the Chinese space station without actually having to perform an extravehicular activity. And this is quite this is a game changer because, again, saves time, saves money, and also makes things safer. And the way it works is that basically the astronauts are able to transfer. The smaller compartment in here is an airlock. And so the astronauts are able to open the hatch between this airlock and the working compartment, and they put the systems, the payloads, the experiments in there with a sliding mechanism, and they close the door, and then the air in the airlock module is pumped out, so a vacuum is created, and then the experiments can then come out through this door, and then you have a robotic arm that grabs the experiments and then puts them on the correct attachment point somewhere here. And so I do have some images of that. I just want to show you guys what this looks like. Just bear with me for a second. There we go. If I open this, for example, yes, excellent. And so this is what the airlock module looks like. Okay, so the payload airlock. And so the astronauts open the hatch they open the hatch to put the payload on. There's a transfer system that works with a sliding mechanism, and then they can push this mechanism back. They close the hatch. Again, the air is pumped out to create a vacuum in there, and then the second hatch is open so that the experiments can slide out. And this transfer mechanism can rotate 90 degrees, and then it can slide the experiments out. And again, from there, the robotic arm then grabs the experiment. Okay. And if we go back to the SketchUp module, trying to think if there's anything else I can cover on this module. For anyone that's joining the live stream at this very moment, so we have the launch normally in 30 minutes-ish, and it's, I don't think it's a scrub. I mean, I'm currently checking at this very moment. The live stream from CCTV is going on as normal. Fueling is still going on. And so there doesn't seem to be, there isn't an issue from what I can see, because there were concerns about having high winds, leading to a scrub. But so far, so good for now. Just checking on another screen, making sure that things are still going on as planned. Okay. All right, guys. Let's move to some other things that I had prepared for you guys. Sorry, just lost myself for a while. There we go. Yeah, so just one final thing I wanted to add on this this 3 render. Something that's pretty cool when I learned that is that this Wenchang module, in the very initial plans of the Chinese space station, this compartment wasn't supposed to be this cargo transfer compartment. It was supposed to host the Mengtian Space Telescope. So that sort of Chinese equivalent of Hubble. That's supposed to be launched in 2024. It's not really an equivalent of Hubble. It's a quite different telescope, actually. But it was supposed to be inside the Chinese space station, which would have been a great advantage in terms of maintenance and servicing. But then, after several rounds of studies, it was decided that, the vibrations and the activity on the Chinese space station would be affecting the telescope, the astronomy activity. And so this was scrapped, and the Mengtian telescope was made to be into a different different spacecraft that would co-orbit with the Chinese space station, that would dock with the Chinese space station if there was a need for servicing, but it would not be, part of the space station. And so this is when this cargo and pressurized cargo compartment, this payload compartment, was designed for the Mengtian experimental module. There's a question on what is the total weight. That's a good question. And so I don't have the answer from Mengtian, but it should be really close to what the weight of Wenchang, which was 23 tons. And so we're actually getting really close to the weight of the, the maximum weight, the payload capacity of the Long March 5B, Long March 5B into low Earth orbit. Long March 5B can launch 25 tons. And it's only 23 tons for the, Mengtian and Wenchang are 23 tons. Okay, let's move on to, let's have a little look at the live stream and see how things are going. Let's listen in and see if there's anything interesting there. Let's see if I can bring the sound up.
低温推进剂，尤其是它这个新级采用了液氢液氧的这个推进剂，它这个低温的这个推进剂呢，就容易受到这个推进剂的一个蒸发，就是说在火箭升放之后，它这个
basically they're explaining how the rocket works. Maybe I can cover that directly. So the rocket that's going to launch the Mengtian experimental module today is the Long March 5B. And so it's part of the Long March 5 series. The Long March 5 series consists of 2 rockets. You have the Long March 5, so sort of the standard version, and you have Long March 5B. Long March 5 is for launching payloads into higher orbits. On the other hand, the Long March 5B is for sending things into LEO. And so they have naturally a lot of things in common. You have you have the strap-on boosters, which 4 strap-on boosters for each rocket that has, each of them have 2 YF-100 engines, which are Kerolox engines. So they burn liquid oxygen and liquid kerosene. And then you also have the core stage, which has 2 YF-77 engines. And so this engine burns liquid hydrogen and liquid oxygen. And so this is China's first high thrust hydrolox engine, which is a little bit challenging to make. Using hydrogen noble engines always has challenges due to the very different density and also the very cold temperatures to have hydrogen in a liquid, in a liquid state. And so there are comments also about the white fumes that you can see on the launch pad. And so since we're talking about cryogenic fuels, so fuels that are liquid only at very cold temperatures, so liquid hydrogen, liquid oxygen, you have to fuel the rocket at the very last moment to make sure that that this fuel doesn't boil off. And so this is done several hours before the launch. I believe it starts as early as 10 hours before the launch. And this is provided by fueling facilities that are in proximity that provide the kerosene, the oxygen, and the hydrogen. And this is why you see white fumes that are coming out from the rocket at this very moment. It's because, since the temperature is very cold for the fuel in a liquid state, but you also have the exterior temperature that's much warmer, you always have a little bit of the rocket fuel that boils off, the hydrogen and the oxygen that boils off. And so when it boils off, it builds in pressure in the propellant tank, and you want to vent that out. You want pressure to build up in the propellant tank. And so to do so, there are venting holes. And so this excess gaseous hydrogen and oxygen is sent out. It's gaseous, it's a bit warmer than the liquid state, but it's still extremely cold. And so when that goes in contact with the ambient air, which has humidity, that creates, it condensates the water that's in there. It's not, those fumes aren't actually the propellant that are coming out. It's the humidity in the ambient air that's condensating, condensating or condensing, condensating probably. And that's what's creating those white fumes. You can see the beaches in Wenchang. Wenchang is one of the 4th launch sites of China, and it's really the most accessible because the other ones, Zhouquan, Xichang, and Taiyuan, they're pretty much inland, and they're historically they're a bit more hush-hush, military controlled to some extent, and so you can't just go there, especially as a foreigner. But Wenchang is much more accessible. First of all, it's a coastal launch site, and it's sort of C-shaped, right? Sort of the coast, and so you can go to the other side of the sea. See the letter C, which is the shape of the coast. You can go on the beaches, and you can see sort of the launch site really close. So they're still checking the rocket at this moment, so definitely not a scrub. From what I can understand. And so, just going back to the beaches we were seeing, this is now a frequent site whenever you have a launch in Wenchang, so a Long March 5 or a Long March 7 or a Long March 8. You have crowds that build up on the beach and to watch the launch. And you actually have hotels. There's a very famous hotel, the Hilton Hotel, that's on the other side of the launch site. And you can see on the website of the hotel that they actually market their proximity with the launch center on their website. You can see the launch happening from one of the balconies from one of the rooms. So that's pretty cool to see. There are, of course, other hotels that are more accessible where you can have a view of what's going on. Just listening in again.
空间站梦天实验舱将搭乘长征5号 B 遥4运载火箭发射升空。现在距离梦天实验舱的发射只有不到30分钟的时间了。接下来我们就通过一段动画演示来了解一下今天承担发射任务的长征5号 B 运载火箭。长征5号 B 运载火箭是空间站舱段的专属座驾。
So again, talking about the Long March 5B. So I can cover that. Basically, as you can see here, the rocket is 53 meters tall. This is the most powerful rocket currently in China's lineup of rockets, but it's not the tallest. 53 meters, this is less than, for example, the Long March 7A, which is around 59 or 60 meters, and which is the tallest rocket in China's current lineup. It's definitely the largest in terms of diameter. It has a core stage with a diameter of 5 meters, and it's the only It's the only rocket that has such a large diameter in China. All the other rockets in China generally have a diameter of 3.35 meters. There's a very good reason for that, is that notably for the launch sites that are situated inland in China, so Zhoushan, Taiyuan, and Xichang, you get there by train, right? You send your rockets through the rail system, and since there are tunnels, the maximum that this ecosystem of tunnels in China can fit through is a diameter of 3.35 meters. That's why all Chinese rockets have that diameter, except for the Long March 5. Since it's launching from Wenchang, it is no longer sent there through rail. It is sent there through dedicated cargo ships, and it's unloaded directly in Wenchang. So there are no issues with the rail limitations.
10, 9,
So we have a countdown here. It's a fake countdown. It's practice
这个
basically.
其实也算他最后城市的一个演练的一个过
对
程。
所以要跟观众朋友说明一下，现在这个到底
Yeah, that was not a real countdown. So this is generally what they do 30 minutes before the launch, and they simulate a countdown to make sure that everything is working correctly. Okay. One difference also, one thing that I want to mention about the Chinese space station and a difference, about the Long March 5 being a difference with Long March 5 is with the core stage. And so when you look at the center stages, the Long March 5B only has one, while the Long March 5, the standard version, has two. It has an upper stage. And this is quite an unusual configuration for the core stage, to only have one core stage on the Long March 5B. And this means that the core stage on the Long March 5B acts also as an upper stage. So it has the role of bringing, the payload to orbital velocity. And this this naturally presents a little bit of a risk. And this is where there's a bit of quite a strong controversy internationally, because since the core stage reaches, orbital velocity, then it stays in orbit at much longer amount of time. Generally, it's a couple of days, and so the decaying is much slower, and the landing area of the core stage of the Long March 5B becomes more unpredictable, and it's literally unpredictable, apart from maybe a couple of minutes or a couple of just 1 or 2 hours before it takes place. And it performs an uncontrolled reentry in the sense that there is no firing of thrusters or other mechanisms to choose the landing site or the crashing site of the Long March 5B core stage. And since it's a pretty big core stage, it has a mass of 20 tons. This does create, some risk for humans and facilities on the ground. I believe the Aerospace Corporation had compiled a figure of one in 600 or 1 in 1,000 chance of it generating some level of damage. So the percentage that it harms anyone here that's listening is 1,000,000 times lower than getting hit by lightning, but it's still considered a bit substandard in the sense that, for example, the U.S. Sets standards at for launches at at most 1 chance out of 10,000 of creating any damage during reentry, and it hasn't always respected that rule, but this rule is what it is. It's a standard, and so the way I understand it, how the Chinese see this Long March 5B is that basically, or this was my understanding actually until a couple of days ago, which is that the Long March 5B is a rocket that's really dedicated to the Chinese space station, right? And so it's just launched a handful of times. And so if you launch, if you have a rocket that's 10 times more dangerous than another rocket, but then at the same time it's launched 10 times less, I would think that the overall risk in the launch history of the rocket remains contained and comparable to the other rockets. So the Long March 5B was launched once in 2020 as a test. Then you had Tianhe last year, you had Wenchang this year, you have Mengtian today, and you have possibly Shuntian in 2024. So that's 5 launches in total, and so that's significantly less than another high frequency launch rocket, such as there are rockets that have been launched hundreds of times over history. So I think that's how the Chinese see it, despite all the criticism that they get. Now, I would like to add that a couple of days ago we did see the chief designer of the, I think, Long March 5B, who said that the Long March 5B would be used beyond just deploying the Chinese space station for things like, like deploying constellations, batches of satellites for Chinese constellations, which means that the Long March 5B could be, used, many more times, launched many more times, in which case, what I said about mitigating risks by reducing the number of launches isn't exactly true anymore. I know that the Long March 5B, according to the chief designer, they mentioned that it would be fitted with the Wenchang upper stage, which is an upper stage that is used occasionally on other Chinese rockets. So there will be modifications to the Long March 5B. Now, it's unclear today if these modifications will result in better anticipation of when the rockets will come back and will re-enter. So that's still a mystery to me, and we'll have to wait and see. But it's interesting to know, at least, that the Long March 5B will have a carrier that will go beyond the Chinese space station. And actually, I saw a piece of news from a couple of months ago saying that the same thing for the Long March 5. So the Long March 5B has a fairing of 19 meters. It's huge to be able to fit the various modules of the Chinese space station. The Long March 5, on the other hand, it has a second stage, it has an upper stage, but it has a smaller payload fairing that is 12 meters long. And so the idea of the upgrade of Long March 5, from what I understood, is that is basically that it would be upgraded, would be extended to 19 meters as well. So China can really fit batches of satellites in there for deployment of constellations. So I'm not sure which role if the Long March 5 or the 5B is going to play the more important role in the future for constellations. We'll have to wait and see. I do have a question here on what is the ETA for launch. So as you can see here on the screen, it's in 18 minutes. I do need to correct the time here on my countdown. So let me just do that now. Bear with me. And I'll just answer some questions at the same time. So Raf XD has a very interesting question. Why does China have 4 launch sites? Why have 4 when you could have 3 or 2? And like for example, US is mainly launching from 2 launch sites. Typically Falcon 9. And so it's for historical reasons. So the Chinese, their space history goes back to the 1950s. Their first launch was in 1970. And back at the time where, we were in the middle, the Chinese were in the middle of everybody, all countries were, it's the Cold War era. And so China has unfriendly relations with both the Soviet Union and with the US. And so the idea was to build launch sites that were further from borders as possible, and so inland. And so that's why you have, so Jiuquan was built in the northwest, but was, so it was the first launch site, but it was uncomfortably close to the USSR. So they then built Taiyuan and Xichang that were really inland to, protect from any potentially any intervention from foreign countries, hostile countries. It's worth noting also that Xichang, the third launch site, is significantly more south for launches into geostationary orbit. Naturally, it's nice to benefit from the tangential velocity of the Earth as it is rotating. So it's nice to have launch sites further down south. The launch sites that are further up north in China, so Jiuquan and Taiyuan, they don't launch into geostationary orbit, so they're not affected that much by not having that additional boost of the Earth's rotation. Okay, now the final launch site, Wenchang, the 4th and final launch site, was built recently. Entered service only a decade ago, roughly, and even less than that actually. In 2015 or 2016, I think the first launch was of a Long March 6, and Wenchang has the advantage of being even more south than Xichang, and so it's really great for launching into geostationary orbit. It has a latitude of 19 degrees north, I believe, and it also has the advantage, as mentioned just now, of bypassing all those issues linked to having a limited railway system that forces you to have rockets that only have a limited diameter of 3.35 meters. And so that was what the 4th and final launch site was about in China, the Wenchang. and it also, it's a coastal launch site. It's worth noting, so it's more vulnerable, so to speak. And China built it there because it was built a decade ago, 15 years ago, at a time where China was getting a bit more confident on its capabilities of defending itself, having a more capable military and not having such big a gap as maybe a couple of decades ago compared to the USSR and compared to the US. So what we just saw was the black umbilicals disconnecting from the fairing, by the way, and that is basically the air conditioning. And so basically, there we go. No more air conditioning for the core module, not the core module, the Mengtian that's inside the fairings. So it will have to rely on, basically a thermal insulation that is, within the payload fairings. I guess the temperature in Wenchang, is pretty mild. I mean, it never gets too cold or too hot, and so especially in this season right now, and so there isn't need for I guess that much air conditioning. I think one thing that's maybe a bit more irritating in Wenchang is the proximity with the sea, which creates humidity and also some saltiness in the air, which can have some corrosive effects, I believe. And so that's something naturally that's taken into account as the rockets are designed. But just some general information on Wenchang. So that's great. Let's just see what they're discussing at this very moment. We're 13 minutes now from the launch, according to my countdown. I'd like to see the CCTV countdown just to make sure it's synchronized, but we're getting really, really close to the launch. Okay, actually really close. Just a 4-second gap between the two. So yeah, guys, maybe share in the chat, how are you feeling about this launch and about the launch of Mengtian? What do you think about this, the Chinese space station?
合适的发射的轨道高度，让它用一个最省燃料的方式去把一个足够尽可能大的一个燃料的载荷去打到那个轨道上去，这样的话它的效率会更高。
I'm hearing double voices here. Maybe I need to mute one of them. Mute this. There we go. There we go.
组合体就等在那儿不动，它其实2个航天器都在跑，在跑的过程当中要交会对接，所以对于这个发射窗口的要求就会特别的高。
没错，尤其是执行这种交会对接的任务。
Okay, they're talking about the docking, so I'll answer that. I'll explain that in detail in a bit. Zhang Yuguan asks, is that a Juche model in the background? Thank you very much for asking. This is a Juche 1. So this is pretty hard to find now today. This is the first rocket that was designed by Landspace, one of the commercial companies. It didn't have a very good career. It launched once, it failed. But it's the first attempt from Landspace, who's going to launch its Juche 2 liquid fueled rocket, normally in early December, the first Methalox rocket in the Chinese launch landscape. And so this is something I bought when I was in China. They have a nice WeChat store. That's where I got it. They don't sell it anymore. But that's what I was saying at the beginning. At Dongfang Hour, we opened a merch store because we realized it was really hard to get your hands on, on cool merch when you're outside of China. So yeah, that's the Juche model that I generally put in the background of my videos. Nice catch. Excellent. I just want to take 10 seconds also to thank the other viewers that have supported the channel, that have done, super chat and super thanks. So special thanks to, there was notably, there was Dale, there was Microsoft 303. Always love your work. Keep it up. Thank you so much for your kind words. There may have been some that I missed. I'm very sorry if I don't call out your name. I was too much into the presentation, but in any case, I'll see it after the live stream. Thank you so much for your support. It really means a lot to me. Just seeing, looking at some of the other questions before the launch. Do you know if there are any plans to send foreign astronauts to the Chinese space station? The answer is yes. There was Yang Liwei, who is the deputy chief commander of the whole crewed spaceflight program, and so he's actually the first astronaut as well. And he mentioned, notably, that once once the Chinese were past the construction phase of the Chinese space station, so normally next year, it would be open to foreign astronauts, and so. Typically, I had heard that some ESA astronauts were learning Chinese, notably Thomas Pesquet, I think, the French astronaut. And so they were learning Chinese. They were also training between ESA and CMSA astronauts over the past years. I think in 2017, there was one session in China. There was one session also in Europe. And so it's very likely that we will see an ESA astronaut on the Chinese space station. I hope that will be the case. You also have, potentially close allies to China, like Pakistan, Suparco. You could have those space agencies send astronauts on the Chinese space station. However, very unlikely is probably the U.S., unfortunately, due to the rather cold, looking for a stronger word than cold, relationships between the U.S. and China at the moment. Russian, so cosmonauts, probably yes. I mean, Russia and China have a pretty close relationship, and as Russia is trying to distance itself from the International Space Station, and it doesn't have a space station that's operational at the time, Russia will probably be one of them. And especially, there's proximity also in the technologies. For example, Soyuz has some proximity with Shenzhou, and so I guess training will be much more straightforward as well. One thing to note, though, is that due to the inclination of the Chinese space station, it's impossible for the Russians to launch a Soyuz and for it to dock with the Chinese space station because it's the launch site is not at the correct latitude, and so very likely for an astronauts possibly as early as next year. Looking at some of the other questions, Chinese people here on the chat, how is the current private Chinese space market? That's a huge topic in itself. So just very briefly, you have over 15 to 20 launch companies, commercial launch companies that have been started since 2014 in China. You have those that publish a lot, that look very promising, that raised a lot of money, and so it's Galactic Energy, it's iSpace, it's Landspace, you have Deep Blue Aerospace, a couple of others that are fairly advanced. You have the most advanced ones, and it's generally those that have raised the most money. Of Landspace, for example, that's attempting the first launch of their rockets, the Zhuque 2, the liquid-fueled Zhuque 2, in December. You have iSpace that will be testing vertical takeoff and vertical landing, sort of hops a little bit like what SpaceX did in the early 2010s. So that's next year. So potentially a maiden launch end of 2022 or in 2023. You have Galactic Energy that has plans for its Pallas 1, a Kerolox rocket that's supposed to be reusable, to have a maiden launch, I believe, at the end of 2023. So those are the most promising ones. You have Deep Blue Aerospace that performed vertical takeoff, vertical landing with a small 7-meter high prototype rocket first stage. Again, to master the technique of VTVL. And so those are the most promising candidates. And there's a launch bottleneck in China today. So there's the question of, there will definitely be a market for them. You can see that a lot of the commercial satellite companies would like to launch, but have to sort of squeeze in, the launch program of the state-owned Chinese satellite programs. So there's a market for them. That being said, I think there's 15 to 20 launch companies. That's really way too many. And so we're likely to see mergers and to see, some of these companies die while others survive. And I think it was the CEO or the CEO, I think, of iSpace that mentioned at some point that he expects really on the long term 2 of the commercial companies to thrive long term. That's that. Again, I don't want to go into a rabbit hole. There are very different technologies that are being explored by these commercial companies. They're vertical takeoff, vertical landing. You have some oddballs that are also looking towards spaceplane technology. So different technical solutions that are being considered. We have an episode on that actually on Dongfang Hour that from a couple of months back. You can check that out. It's not exactly up to date. I mean, it's 6 months old now, but still a lot of good information in there. Any other questions? Let me just listen in. Sorry, before answering some more questions.
我们原来在货船上已经验证过的遥操作交会对接这种事情，就是我们的这个空间站是具备到了一定的阶段之后，如果别的系统出现一些小问题，我们航天员是可以接手过来，在空间站这边、天河这边来控制我们的梦天舱。
Wow, cool to see! I just saw that there were more than 1,000 viewers in the live stream. That's ultra cool. Thank you so much for watching. All right, guys, we're 4 minutes away from the launch. Once we're 15 seconds, 20 seconds into the before the launch, I'm going to start talking so we can watch this moment together. I just want to give a little bit more context on what we're going to see. So we're going to see the launch. The 4 strap-on boosters, they provide 90% of the thrust at liftoff, and those are roughly, I believe, booster separation takes place at 170 to 180 seconds into the launch. And then, at a later stage, you have the main engine cutoff. You have the separation between the core stage and the upper fairings. This takes place at a much later stage compared to other launches because remember, the Long March 5B, the core stage is the first stage, but it also has the role of taking the payload to orbital velocity, and so it acts as the upper stage. I think the separation takes place at least 300 or 400 seconds into the launch, if I'm not wrong, and so we'll see that very soon. And during the launch, we're going to see hear things, like we're going to hear the ground stations call out in China. So telemetry and tracking stations. So you'll hear things like, Huashan, Qingdao, Sanya, things like that. And so what that means, what we're going to hear is it's just the tracking station that's saying, so tracking station name, and then, everything is normal, this is the situation. And it's just really just some background on those names. When you hear Sanya, Qingdao, Huashan, things like that, the reason for that is those names are generally the area where the ground station is situated. So Sanya, a coastal city in the south of Hainan. You have Qingdao, a city that's in the Shandong province. But it's not the case for all of the ground stations. So you'll, for example, hear Tianshan. So I know Tianshan, it's these mountains that are in the north of Xinjiang. The ground station is not actually situated there. It's in Kashgar, but since the ground station, is named after one important landmark that's situated in Xinjiang, just to make it a bit more poetic, I guess. And the other one, the most interesting one, is Huashan. So Huashan is the name of these beautiful mountains that I visited, by the way, in Shanxi province. And the reason for that is because this ground station is actually situated in the city of Xi'an, which is the main sort of control and the tracking center for all space programs in China. But basically, this ground station, historically, the facilities of this control center, historically, it was more to the east of the city in a city called, not in Xi'an, actually, in a city called Weinan, which is at the footsteps of Huashan. And so that's why historically it's called Huashan. And so there are many different reasons for the names of the ground stations.
1分钟准备，1分钟准备，120接通，允许点火。
So you hear that? 1分钟准备 1 minute, 1 minute. Get ready for the 1 minute countdown.
50秒。
Okay, guys, this is getting pretty exciting. Lee Chow says greetings from New Zealand. Hey, 1 minute.
30秒。
Okay, guys, this is it.
20秒。
The wind seems reasonable on the side right now, so I guess it's the high altitude winds that matter more, but still interesting.
10、9、8、
Okay, guys.
7、 6、5、4、3、2、1，点火！
点火。
And engine ignition, the water suppression system, sound suppression system.
机鸣150 3拐分2.3秒。
And we have a liftoff of the Long March 5B carrying the Mengtian experimental module for the Chinese space station. Just the sound.
阵地315公正常。文昌光学雷达功正常，遥测信号正常，文昌飞行正常。
Tracking station speaking,
正常。
saying, telemetry okay, tracking okay, blah, blah, blah,
遥测
okay.
信号正常。
You see that the core stage flame is different.
正常。
Is different from these side boosters. So I'm putting this a bit less loud. There's a reason for that. It's because the side boosters, they burn liquid kerosene and oxygen, so you get this bright orange color. When you're burning hydrogen, on the other hand, you get this more transparent flame, and that's why the rocket plume looks different. And
同步岭遥测信号正常。
Tongguling, that's again name of another ground station.
文昌光学雷达功能正常，遥测信号正常，文昌飞行正常。
Okay, so we're going to cover as soon as things start happening after, we get past 200, 300 seconds. I'll start discussing how Mengtian docks to the Chinese space station. There's a lot of cool stuff to discuss
现在
there.
我们可以看到这个尾焰，
阵地
尾焰的温
315
度大概有多
功能正常
少？。
这个火箭发动机的尾焰温度大概在2500度左右。
So another cool thing, as you can see, the rocket plume is getting wider and wider and forming a larger and larger cone. And the reason for that is that as pressure drops, as you increase, the rocket increases in altitude. Due to the higher pressure that's within the rocket plume, the plume just normally expands like this. And so when the pressure is equivalent inside and outside of the plume, you have the plume that's a straight line. When it's there's a lower pressure outside, it's an open cone, and when the pressure is higher, then the cone is sort of closes in, and that's something you want to avoid because you can get some pretty nasty stuff when that occurs. But that's why the cone is getting bigger and bigger, and it'll continue to get bigger as we get closer to the booster separation.
西沙313功能正常。
这里也可以看得很清楚啊，这4个助推器的它的这种斜锥头的设计。
对。助推器关机，助推器分离。
And we have booster separation. Everyone clapping naturally. This is a stressful moment.
文昌光学雷达功能正常，遥测信号正常，文昌飞行正常。还可以在这个隐约的看到助推器的这个情况。
And so there are cameras that are inside the fairing. There are also cameras on the outside. I believe I had this figure. I think the Long March 5B has up to, is it 20 different cameras available. So you have them inside the fairings, you have them on various areas. Basically, it's nice, obviously, to transfer these images for the ground for the public, but it's also used by ground control to make sure that critical areas we can have a view of what's going on. So typically to watch fairing separation that just took place here, but also for booster separation, the connector points, things like that.
它采用一个旋炮式的一个分离方式。我们可以从这个画面当中还可以看到分离出来的整流罩。
So the fairing naturally is there to protect the payload as the rocket is increasing in altitude, is going faster and faster. Naturally, when you're in you've reached a significant sufficient altitude where the atmosphere is low enough that you don't have any impact of the speed. You don't have any drag or less drag, or how can I say this? Basically, the atmosphere doesn't impact the payload any more than the fairing is no longer useful, and then it is, it is discarded, it is jettisoned.
因为大所以它的设计包括分离的设计
方案都不一样，
小的不一样，
对，不太一样。
那接下来，舱舰分离的时候，是不是也要有一个特别的设计？
没错，它那个
Something that's
另外一个
So once we're going to have the separation between Mengtian and the core stage, what's going to happen is that Mengtian is then going to do two very important things. The first one is extend the antenna so it can communicate with the relay satellites, and it is also going to extend its solar arrays. And the reason why it extends its solar arrays naturally to get power, solar energy, harvest solar energy, so it can power all the electronic systems and not just rely on the battery. But in the case of Mengtian, and it was also the case for Wenchang, the batteries will extend, the solar arrays will extend up to 6.5 meters. And it won't extend completely. Remember, I mentioned that the solar arrays have a total length of 55 meters. The reason for that is as it will dock to the Chinese space station, well, one issue is that potentially, as mentioned, the solar arrays are very thin. It's pretty wobbly infrastructure, and so you don't want it to be too unstable as it docks, because what you want to avoid typically is that the solar arrays are completely extended and then you dock with the Chinese space station. The docking creates some sort of vibration which are amplified by sort of the wobbliness of the solar arrays, and this wobbliness, the core space station then senses it. It tries to correct with attitude control thrusters, but then this creates more vibrations and more wobbliness, so wobbliness, not the scientific term for sure, but more wobbliness, which creates another reaction from the attitude control system, and then this could engage into a pretty negative loop. And so that's why these are only extended, these solar arrays, as we'll see further down the launch, they're only extended a little bit.
火箭和这个有效载荷就分离了。从现在时间来看，可能还有1分钟的时间，我们再静静等待1分钟，
就可以入轨了。
雷达中正常，遥测向正常，文昌飞行正常。
So 1 minute before separation. Maybe I can answer.
现在我们看到的是从梦田舱上传回来的画面。
西沙313更正常。
我看看啊，这个应该是支架上面的。
对，就是有效载荷支架去照这个梦天实验舱。
对，是火箭这边的支架拍的，应该是。
How long will it take to dock with the space station? That's a good question. It's what the Chinese called fast docking for fast docking. So fast docking can mean different amounts of time. Fast docking for the Mengtian and Wenchang modules, we're talking about 13 hours. It was 13 hours for Wenchang. It's also the case for Mengtian. For Shenzhou and Tianzhou, when the Chinese talk about fast docking, we're talking about 6 to 6.57 hours. It used to be much longer than that, but there were changes that were implemented to make sure that astronauts didn't have to stay in the Shenzhou spacecraft for too long a time. So there we go, separation. People getting excited in the control center.
大家可以松一口气了。那入轨的精度怎么样？还需要进一步的。
它要核算一下。
再要核算一下。
但是从整个的发射过程来看，我觉得这应该是一个高精度的入轨。整个过程非常的平稳顺利。
高精度的入轨对于后续的交会对接会带来怎样的好处？
就是它给我们的梦天下一步去交会对接给了一个非常好的起点，就是它的这个起点的精度有点像我们开车的这个导航。当你比如说
So we're talking about docking. I want to talk about that a little bit. So 13 hours, what is Mengtian going to do during 13 hours as it docks with the Chinese space station? So it's going to dock with the front docking nod of the front docking port of the multi-docking nod of the Tianhe core module, and the final destination. Actually, I have. Let me get something. I have this absolute horrible module of the mirror space station, but it looks a little bit like the Tianhe core module, the Chinese space station, and so we can sort of sort of use it. Basically, what's going to happen is that basically the Tianhe, the Mengtian experimental module is going to dock with the front docking port of the Chinese space station of the Tianhe core module, but its final destination is actually going to be on the side. And so how this is done is that Mengtian has this small indexing arm. So first it docks with the front docking port. This is fairly classical, just like Shenzhou. You have a soft capture ring, and it docks, and then the ring pulls Mengtian in, and then it locks the two modules together. And actually, the next move of having the indexing arm move this Mengtian to the port side docking port, this takes place at a much later stage. For example, for Wenchang, they waited a couple of months before doing it. For Mengtian, it probably won't be that long because the Shenzhou 15 crew should arrive at the end of November, so they probably want to get things done before that. But basically, yes, this should take place a couple of days at least after the docking of Mengtian. And so there's an indexing arm that grabs the core module over here, and that then, Mengtian undocks with its docking ring, and the arm pulls it to the side, and then again enables it to securely dock with the side docking port. And so some people might ask why doesn't the module dock directly with the Tianhe core module multi-docking node port side docking port? And the reason is that it's not a docking port, it's a berthing port, meaning that it doesn't have all the necessary equipment like the radar systems, the LiDAR systems to enable direct docking. And so only the front docking port has that, and the radial docking port. And so this is why. And probably another reason is that docking directly to the side has some challenges, I would guess, than compared to just docking traditionally in the direction of the Chinese space station to the front docking port, which is what the Chinese have been doing for a while and that they're familiar with. I have an animation. I'm not going to show it just yet because things are still happening, but I can show you. That explanation with the mirror space station wasn't good.
火箭打得准不准，精度怎么样？怎么来判断？
我们在发射完之后有一个快速评定的一个过程。
文昌报告。下面请文昌发射场区指挥部邓红琴指挥长宣布发射任务结果。
So Lagrange way, do you know if China uses Li-ion batteries or fuel cell batteries? I think it's Li-ion, but I'm not sure. To be confirmed. I'm not sure. Okay, they're going to announce a launch success.
专家同志们，根据长征5号 B 遥式运载火箭飞行数据和北京航天飞行控制中心监视计算，空间站梦天实验舱已准确进入预定轨道，工况正常。现在我宣布，此次发射取得圆满成功。
Yeah. So 圆满成功 in Chinese, it's full success, and you get this traditional red screen in the background, which means that launch success. And historically, this was done when the solar arrays were deployed and the antenna was raised, because those are pretty critical moves for Wenchang and also for Mengtian. They don't do it anymore. I don't know why they don't wait for that. I guess because again the solar arrays are not completely extended. So that's a good question. But just for Mengtian, we should see the antennas deploy in a bit. So yeah, this is basically traditionally this is selfie time. Everyone's going to go in front of that screen, shake hands, and take pictures. Okay, guys, I'd like to show.
我们要热烈祝贺空间站梦天实验舱的发射任务取得圆满的成功哈！两位嘉宾，你们都是可以说一直是参与到了这个任务当中啊，所以听到这个宣布成功的这个消息，你们是什么样的心情？
best English content for a Chinese space program. Thank you so much. That's very kind.
因为这一次宣布成功跟之前的这个意义又不一样。虽然说我们看了很多次的大红屏啊，每次发射成功以后都会有大红屏，但是这一次的意义又特别的不同，跟以前。
就是它给我们的这种，就是历史上的一个重大节点的那种，就是感觉特别。
Okay, they're describing basically what their, with their emotions, things like that. I just want to show maybe, I just want to show really quickly before returning to the stream, some things regarding what I was saying about the docking port, the berthing port. And so I have a part here. And so let's see. Okay, this is, the half extension on Wenchang of the solar arrays, 6.5 meters. And then this is when the solar arrays are fully extended. The full extension will only take place when the experimental module is securely docked with the front docking port of the Chinese space station. Okay, here's another picture. And one thing that I want to show is what I was talking about regarding berthing. So there was a nice CCTV animation from the previous live stream that I want to show here. So this is what happens, right? So the Chinese, the Mengtian docking port was docked to the front docking nod, but then it is moved to the side by this indexing arm that grabs one of the endpoints that you see at the bottom here on the multi-docking nod. And then it moves Mengtian to the port side docking port. And this is what it looks like. And you can see that here, once it's moved to the side, the indexing arm has 2 degrees of liberty in rotation, 2 joints. And then it pulls it in, and then you have the soft docking ring that then extends and then pulls the experimental module in to connect with the side docking port. Okay, and so this is what it looks like. Actually, I have real footage, so let's watch this one instead. So this is exactly what's going to take place. So this footage is for the Wenchang experimental module, so the module that was launched a couple of months ago, and it does exactly the same thing. It has exactly the same indexing arm. The indexing arm grabs a different endpoint and goes to a different side of the multi-docking nod, but it's exactly the same. And here you can see that Wenchang was docked to the front docking port. It's now undocking. You have the soft, docking ring. I forgot what's the exact name. And you see that this indexing arm has 2 degrees of liberty in rotation, and so it will slowly rotate Wenchang and so also Mengtian to the side. And you can see here this was the robotic arm that was watching and filming the process, because the robotic arm has cameras. Okay, and so here you can see the Wenchang module that was slowly moving to the side. Once again, we're going to have exactly the same thing for Mengtian take place. And so this is a fairly slow process. Again, this is not going to take place today. This is going to take place at a later stage when possibly a couple of days or even weeks later, once they're sure that Mengtian is securely docked to the front docking port, all the systems are fine, then they can take care of this. And here, once again, this is still an image of Wenchang slowly exiting, getting further and further from the front docking port to move to the side docking port. This footage, I think, lasts 2 minutes. And so here you can see that Wenchang, it will also be the case for Mengtian, is getting closer to the side docking port. This is what you're seeing here. You see the rotational parts of the indexing arm actually sometimes work together, sometimes work separately. There's actually a 3-step process that's hard to explain here. But it's to align the 2 modules, the 2 docking ports, and then you have that ring that extends to grab, the berthing port of, on the port side of the Tianhe core module. And once that's secured and it's locked, and then it pulls the Mengtian space station in. So this is not Mengtian we're seeing here. It's Wenchang. I think it was last month, but we're going to see exactly the same thing for Mengtian. Okay, I hope this clarifies things. Moving back to the live stream.
什么样的准备？
梦天上呢还要进行相应的调姿变轨，做好和空间站组合体的对接准备，为后面的转位和形成组合体的大构架做好相应的工作。
Talking about the next steps.
那交会对接之后，它还要接受哪些考验吗？
交会对接以后呢，我们还要进行这个转位。 还有整个状态的设置，太阳翼的全面展开，阿尔法的全面对日定向，还有整个系统的。
Okay. Feel free to ask questions in the chat here. Again, I may have missed some of them. Let me try and answer some questions, and I'll discuss also some of the milestones as Mengtian is getting closer and closer to the Chinese space station, the Tianhe core module. Let me see some of the past questions. Dale L, do you know if China's docking port is IDSS Rev F compliant enough to have the ability to dock with the NDS, so Starliner and Dragon ports? They look similar. Indeed, that's a good question. I don't know, and I've seen conflicting accounts answers to this question. So I unfortunately, I don't know the answer to that. If anyone knows the answer to that, by the way, do post that in the comments, because it's really interesting to know what is the intercompatibility between, Russian and Chinese and U.S. standards. I would tend to think that the Chinese probably would have had something, a docking, sort of standard that would have been compatible or similar to the Russian standards. Good question. I am not familiar enough with this topic. What's next? Sue MZ. Hey, I'm curious what experiments need exposing to space. Well, basically, when you have an experiment that is on the outside of the space station, it's exposed to pretty harsh solar radiation. And so that can be really interesting to see how, potentially how microorganisms or how plants or how seeds can have some mutations due to solar radiation. And that's something that the Chinese actually have they've really specialized in this over the past 30 years of sending things into space, exposing them to solar radiation, seeing how they change, and potentially having genetically modified, crops that perform better. And so that's something they've done. I guess that's one situation where you would want that. There are possibly others. I don't exactly know. But, I think there are 47 or 50 attachment points on the outside for experiments on the Chinese space station. So obviously there's something there. There's a lot of things to study. And you have the same thing actually on the ISS. The ISS has a Kibo module. The Kibo module is similar to the payload compartment on the Chinese space station Mengtian module to transfer, scientific payloads outside without having to perform an EVA. So Kibo on the ISS does that, and they also have areas where they can put experiments on the outside. So it's pretty commonplace. Both the ISS and now the CSS are going to do that. Eric Leo says, no, they are not compatible. So we're talking about the docking ports, the standards. Thank you so much for answering. That's good to know. Vengeance Recovery says not compatible for the US, for Russia. Soyuz, I'm not sure. Zhongbu says it's not compatible. Okay, so it seems that the general response here is not compatible. Eric Liu, they're not compatible, has been clarified by Chinese engineers. Thank you so much for saying that. So I guess if you would want to have a U.S. spacecraft dock, then you would potentially need adapters and something like that, as was done previously between the USSR and the U.S. So here I think they're recapping the launch. Yeah. So answering some more questions. Let's see, is China building reusable launch vehicles or single-stage reusable like the recent ones from Jeff Bezos? So I think there are multiple questions in that. So reusable launch vehicles, I answered that directly. And so single-stage reusable rockets, that is something that is under the Chinese roadmap. You have KSIC, which is a large state-owned conglomerate, which is designing Tengyun, a spaceplane that is, it's not single-stage to orbit, it's two-stage to orbit. But we've also seen other institutes of KSIC that have been developing, quite sophisticated engine technology to enable SSTO. So no definite date, but that's on their roadmap. I think for the 2040s, that's what I saw. So technologies like pre-cooling, and so it's engines that you'd have, for example, on the Skylon, it's being developed in the UK at this moment. And there are, there's also currently a space plane that's in orbit that was launched by China a couple of months ago on a Long March 2F. And so China, so this is CASC on the other hand, the other state-owned conglomerate that's, launching, that's launched sort of a space plane, suborbital first stage, and now, the space plane that's in orbit is an orbital second stage. I would guess similar to the X-37. And so, that's the space plane quite a bit of space plane activity actually in China in recent years. Thank you, Marlev, for your super thanks. Thank you so much for supporting the channel. Again, really appreciated. And just more generally, it's really nice to see so many people, still watching the live stream and, appreciating Chinese space, which is, I think, outside of China, really an underrated space program that's not known enough. And that's why the Dongfang Hour channel exists. I focus really on this niche of the Chinese space sector, which I find fascinating. Let's see what else, what other comments you have. Ken Behrens, thank you for your kind words. What else do we have? How long will it take to dock to the Chinese space station? So I want to answer that question again, but with more detail. So you have 13 hours before Mengtian reaches the Chinese space station. Okay, we're getting into commercials here, so I'm going to put myself in full screen. Basically, 13 hours, there'll be several milestones. There'll be at some point when the Mengtian spacecraft, the Space Lab, reaches 5,000 meters, and then it'll reach a second milestone of 400 meters, and then 200 meters, and then 19 meters before it docks. And when it reaches 200 meters, actually, this milestone is notably used to stop and wait, basically, until there is the correct solar exposure to the sun's rays, to solar radiation. And the reason for that is that a lot of the docking is done with optical sensors, which can easily be blinded if there is too much sun or the sun is not in the correct direction. And so it waits until the time is correct. So it being the Mengtian Space Lab, before moving forward with the final steps of the docking process. And I was going to say something else on the docking process, but I don't remember. Okay, I don't remember. I guess I got up a little bit early this morning. I didn't sleep too well. And, it's been a very short night, and but, it was worth it. This was really, really fun to do. So answering some other questions. Why is the ISS needed when China has its own full-fledged space station? Well, I guess always extra capability in low Earth orbit is worth it. I think the ISS is still an example of international collaboration in space. Hopefully the Chinese space station can become that as well, with, foreign astronauts and foreign experiments that are accepted on the Chinese space station. The CMSA has actually already accepted a first batch of, I think, more than a dozen of foreign experiments on the Chinese space station. And I think the CMSA's policy regarding this basically is that foreign experiments are welcome and they can enter the Chinese space station for free. In counterpart, obviously, in exchange, basically the foreign party, the foreign space agency, has to share the results of the experiments with CMSA, with the Chinese. And so it's this way, it's supposed to be win-win on both sides. And again, as mentioned just now, Yang Liwei, the deputy chief commander, I think, of the crewed spaceflight program, that's his title. He mentioned notably that once the construction phase of the CSS is complete, so at the end of this year, after the end of this year, basically the CMSA is open. The Chinese Manned Space Agency, that's what CMSA is open to hosting foreign astronauts on the space station. Again, likely candidates are space agencies, either close allies of China like Pakistan, but you could also have European, the ESA, which has a history of collaboration with China in space. There have been training between ESA and CMSA astronauts, both in Europe and in China. I even heard that some of them were learning Chinese, because obviously the official language in the Chinese space station is going to be Chinese, although I'm sure English will be used as well. And so, yeah, that's for international collaboration. Let me see if question. Hi, Jean. Will Blaine join this live coverage one of these days? So that's a good question. So Blaine is the historical other founder of the Dongfang Hour. He's been absent from the channel for roughly a year now because he's been focusing a lot on his own. He has his own business, consulting business. Dongfang Hour is a side hobby for both of us. We both have jobs outside of Dongfang Hour. So he has a consulting business in Hong Kong that's also linked to China. That's taking a lot of his time. He's focusing on that. But he's still present, and we're still in touch on a regular basis. And he's interested in joining one of the live streams. So I just saw recently that Streamlabs, which is the software I use to live stream, had added an invitation sort of feature where I can just easily invite someone that's situated remotely. And so I'll be able to add him remotely. I just need to figure out how that feature works. But definitely if we can do sometimes some live streams together. He has a more business perspective that's really interesting. Notably, if you have a live stream of launches of a commercial launch vehicle or constellations, this is definitely an area where Blaine's input will be very helpful. So again, things are going well with Blaine. Hopefully, I can have him join. Have him join one of the live streams. And I just saw that the Super Chat alert box is now working, so you have your name displayed when you do a super thanks. Sorry, that did not work previously. I don't exactly know why. Thank you, Jack Chen and ET, for your generous donations. That is very kind. And let me answer a couple more questions. When is the next launch scheduled? So normally the Tianzhou 5 cargo spacecraft should be launched in a couple of days, I would think, in early November. And that will bring, well, now that there's the typhoon, I'm not sure if that will be delayed or not. But so the Tianzhou 5 cargo spacecraft that will dock with the Chinese space station, presumably to the rear docking port. And so the Tianzhou 4 has to undock before that, probably. And then you'll have normally Shenzhou 15 at the end of November. And so really, at the end of November, actually, when Shenzhou 15 docks with the front docking port of the Chinese space station, what happens is, for the first time, the Chinese space station will have 6 astronauts simultaneously. Now, this overlap is only for a couple of days because the CSS is supposed to have only 3 astronauts. There are 6 sleeping bunks, but the 3 additional sleeping bunks in Wenchang are only there to enable, a new crew of Shenzhou astronauts to replace the former crew. But anyway, a significant moment where you'll have 6 astronauts simultaneously. That'll be probably something that will be broadcasted and communicated about in China. So that's about the calendar. And once we're done, the Chinese enter the operational phase of the Chinese space station. So this is really a part where it's going to use its 14 or 16, I don't remember exactly, experimental racks and produce as much space sciences as possible. That's what the Chinese space station is mainly about. And the next launch after that, so beyond the Tianzhou and Shenzhou missions that will take place every 6 months, there'll be Shuntian, the space telescope, that'll be launched in early 2024. And that is, that's actually not exactly part of the space station. It's not docked with the space station. It's a separate spacecraft, but that co-orbits with the Chinese space station that can dock on a regular basis with the Chinese space station. So that's what's on the menu for the coming year or two. And there's also a lot of discussion on future extensions of the Chinese space station. So, as mentioned earlier in this live stream, there are some backup modules of the space station. There's normally one core backup module, one core module on the ground that was built in case there was an issue with the Tianhe core module. So there wasn't a core, there wasn't an issue, and so it's just sleeping there on the ground. That is not going to be thrown away. Very likely it'll be launched to complete the, extend the Chinese space station to up to 6 modules. This is something that I think it was Yang Liwei, or was it Zhou Jinping? I think it was Yang Liwei who mentioned that, we're looking at the possibility of having a 6-module space station by the end of the decade. So not confirmed, but it's definitely something that the Chinese are looking at. Now, this station, these 3 additional modules would be similar, but also different. So there'd be the Tianhe 2 that wouldn't be called a core module anymore. It's just an additional central module. It brings a new multi-docking nod, and then you have various, modules, experimental modules that can dock to the side docking ports of the multi-docking nod. And some differences will be that these likely won't have massive solar arrays like Mengtian and Wenchang because potentially they could intersect. And, that's not good. And since this large solar arrays of Mengtian and Wenchang provide sufficient power, there shouldn't be a need for new solar arrays. There could also be, we're probably not going to see the same modules inside these extensions because, the same compartments within these new experimental modules because, they'd be redundant with currently Mengtian and Wenchang. So potentially we could see new things like a cupola dome like you have on the ISS or other things to add additional capabilities to the Chinese space station. But all of this is speculation on my part and speculation that's part of the Chinese internet that's, based on things that sometimes people like Yang Liwei have said. So we're going to have to wait and see, but potentially future launches as well in the late 2020s of the Chinese space station. Let me see if there are any other questions. Is it technically possible for Russia to send Soyuz to CSS? So technically no, because the launch site of Soyuz does not work for the inclination of the orbit of the Chinese space station. It maybe could have worked if it launched from French Guiana, but French Guiana was never, the launch site for Soyuz there was never adapted for crewed space flight. But, since the Russians have withdrawn from there, so very likely Russian astronauts will have to go to Wenchang and launch on Shenzhou. But again, there's some similarity between Shenzhou and Soyuz, so the training should be relatively maybe lighter than what it would have been if someone, went from a Dragon spacecraft to Crew Dragon to Shenzhou. Let me see what else there is. Do you planning on doing a weekly update podcast on Sunday? Again, I like those a lot. So, episodes have decreased a little bit in frequency because I'm trying to put more work into each individual episode to really make them really nice, really well-researched, and with the ideal amount of, of animations and visuals. So I used to do with Blaine, weekly updates, and now it's more like once every 2 weeks. But hopefully the quality improves, and it's not a news update anymore. It's just a focus on one single topic, and that just works also better from a YouTube algorithm perspective. So I do have to sort of follow that tendency. But we're working, if you're interested in news, I'm working also on thinking about relaunching the newsletter that we had going previously with Blaine. So if you're interested purely in news, a monthly update of what's going on in China, we may launch that in the future. So stay tuned. With the U.S. blocking the microchip selling and development in China, will there be a delay to the future space launch, Chinese space launches? So the answer is probably no, because for critical systems like the Chinese space station, normally China relies exclusively on locally sourced chips. I know that, I don't know to what extent that is true, but for example, for Beidou, the chief designer mentioned that 100% of the components on Beidou are purely sourced domestically. And naturally you can understand that, right? Because Beidou has, the Chinese equivalent of GPS. It has civil uses, but also military. And so naturally they would want to source this locally. Probably, the trade restrictions probably won't hamper the space program. Probably a bit more, definitely other verticals of other industries, but probably not the space program. What else do we have? I remember that there will be a cargo ship and a cruise ship this year. Yes, so that's what's saying. Yep, Tianzhou 5 and Shenzhou 15 that will be launched. China is also developing. Well, there was a request for proposals for a new cargo spacecraft that was released early last year and potentially open to commercial players. Speculation on my part, but it's the way it was published and written. A reusable cargo spacecraft, as opposed to Tianzhou, which is currently expendable. What's the next streaming? Honestly, unfortunately, I feel that CCTV sometimes is a bit unpredictable. predictable in terms of which streams will be available. So far, it's been available for each launch. I've tried to get in touch with them to get the latest information. If there is a stream for Shenzhou, I'll probably live stream that. If it's a stream for Tianzhou, I probably won't because that's too close with this current launch. But I'll try to cover Shenzhou and also all future, space station launches. It'll be every 6 months, and so it'll be more relaxed. And definitely Shuntian in 2 years, but that's in quite a bit of time. What's the Chinese space budget? So I don't know that. Nobody actually really knows that. There are estimations that are available in various places, in various books. I've read 10 billion, 15 billion. So it's probably, the second space budget behind that of the US. But it's really hard to estimate that also because, these figures aren't necessarily entirely transparent. And so only estimations are available. But there's a good book called China in Space that is published. I have it here on my shelf actually by Brian Harvey. And that gives a good estimation of that. There's a breakdown. Love your t-shirt. Where can I find more China space merchandise? Thank you for noticing. We're officially opening our merch store this week. It's called, it's at the address shop.dongfanghour.com. Let me just do another quick plug if you don't mind. I'm going to show what the shop looks like, and then I'll get back to answering questions. But thank you for asking that. So we launched a merch store because we thought it was quite difficult to find, Chinese space merch outside of China. And so if you go to shop.dongfanghour.com, you see this website where we've designed 4 t-shirts at the moment. They're really designed. This is a Chinese launch site series merch, and really there are a lot of small details that are interesting in the design. Hopefully you enjoy them. You have, for example, the fact that, for example, for the Zhuoquan launch site, we're in a desert environment. So you have the sand dunes. You also have camels. And that is interesting because these are actually animals that you can see during the live streams of, for example, the return of the Shenzhou spacecraft when it lands in the Dongfang landing site. Sometimes you see, camels crossing in front of the live stream camera. So that's pretty interesting. You have the silhouette of the Long March 2F, the emblematic crewed, human-rated rocket that launches from Zhuoquan. You have things like that. If I just go to another one, and then I'll go back to answering questions. You have Taiyuan, which is situated in Shanxi province, a province that's known also for its, having some of the oldest Chinese wooden buildings still standing going back to the Tang Dynasty. So this is why you have a traditional Chinese gate over here on the left. On the right, you have some caves, which are for the Yungang grottos, which were Buddhist temples, I think, that date back to, is it the 7th century? You have the silhouette of the Long March 6, which launches from Taiyuan, and you also have the rocket plume that's a checkered pattern, and that's because this is a photogrammetric target that you see on a lot of Chinese rockets, and that's now pretty much a staple design for Chinese rockets. So if you want some cool merch, go to shop.dongfanghour.com. We just released this series of t-shirts, and we're going to release much more in the coming months. So again, feel free to go there. It really also supports the channel. Thank you in advance. And let's answer some other questions. Any updates to the lunar station? So the lunar station, not really. So there's a previous episode on Dongfang Hour just from a couple of weeks ago that explains this. You have the upcoming Chang'e 6, 7, 8 missions, which are purely Chinese missions, which will take place until 2030 roughly. And then you have after the 2030s, where it's really going to be the ILRS, the International Lunar Research Station, which is China's lunar base, basically. And the details are not very clear yet on this lunar station. There was this sort of handbook that was published in June 2021 by China and Russia, since it's it's led by China and Russia in theory. And so we have some ideas of the high-level objectives, but we don't have any precise definition of what it's going to look like. Because it's still pretty early stage. And I think there's the question of what will the Russian participation look like? Will it be between equals? Because typically, Russia is going to have, due to what's currently happening, some economic issues to fund its space program sufficiently. So that could be a drawback for the ILRS. On the other hand, China will want to move forward with the ILRS. And, Russia may become sort of the junior partner, maybe, of the ILRS. This is just me speculating. We saw that at AIC in Paris a couple of weeks ago. We had China mention the ILRS as basically purely Chinese-led. There were no mentions of Russia at all. That's probably also to attract international partners that aren't necessarily very, close to Russia. And so, again, I think the ILRS is still in a definition phase, so we don't have that many details about what it's going to look like for sure. There are some animations, but it's all CGI at this point. Who will step foot on Mars first, China or Elon? Good question. I have no idea. There's the next Chinese moon mission, Mars mission, the Tianwen-3, is a sample return mission for the late 2020s, early 2030s. It's not crewed. Actually, it's the same thing for the U.S. as well. The U.S. sample return, Mars sample return mission, also around the early 2030s. I think crewed spaceflight is still, further back, unless we have something amazing that comes from SpaceX regarding Mars exploration. But you need funding for that, right? And so I think we're talking more about the 2040s, but that's just my personal opinion. Hopefully, it'll be before that. Is there any international cooperation on research on the Chinese Fast Radio Telescope, since U.S. Arecibo telescope is no longer usable? So I don't really know for this question. I would think probably yes, but again, I don't have the information on that. Looking at will they be waiting for the Long March 9? So the Long March 9 is China's Super Heavy rocket that's currently being designed. There's a lot of uncertainty still at the moment on what the Long March 9 design will look like, because you've had thank you, Gotti Goodman, for your support. The Long March 9, it's not clear at this point what design it'll have. We've seen several sketches by the Chinese chief engineer of Long March rockets, Long Hao. We've seen variants which are reusable. We've seen the traditional design, which is expendable and available in 3 different versions. You have in a recent presentation in Xiangshan, so in Zhejiang province, Long Hao also showed Long March 9 rockets that were based on methlox engines. So methlox, so engines that burn liquid methane and oxygen, and that's a change, because before it was liquid kerosene and oxygen. And so we're in a situation today where the Long March 9 is definitely in development for sure, notably the engines associated to the Long March 9, but this is a rocket that probably will be launched in the early 2030s. The lunar rockets that will be used before that is either the Long March 5, which has already been used for lunar missions, like the Chang'e 5 lunar mission in 2020, and there's also the Long March 5 DY, also called the Long March 5G, which is this new lunar rocket that China is developing that's based on existing engines, so it'll be pretty fast to develop. So they're using improved versions of current existing engines, so the YF-100M and the YF-100K notably, so Kerlox engines that are already used on the Long March 5, but in improved versions. That's what the KMM are for in the name. And so this should be launched. The maiden launch is normally 2026. This date is very uncertain, but this was what was brought up by Long Hao a couple of months ago. Okay, guys, I'm going to have a quick sip of tea as I check out the other questions. Exactly, time to go says for the Long March 9, revision 11, 21, and even a revision 35. So that's Tim to go saying that. So there's a lot of uncertainty on the Long March 9. So what interests me more at this point is more the Long March 5 DY and G, because that's more it's closer term tech that will see the day for sure. What's interesting on the Long March 9, though, is that they've shown in other presentations also the sort of thinking that they've been going through regarding how to land the rocket, and how SpaceX was was exploring beyond just using landing legs, but also chopsticks. And we saw this concept by China of a tethered system that would, sort of like a net that would catch the rocket. So I don't have an image of that there. I think we have a video from the beginning of this year that shows this. So yeah, we're still in the design phase, the definition phase of the Long March 9. It's nice to see the different, more longer term technology solutions that are being explored. Will China use the Long March 5DY to send people to the moon, or Long March 9? So the Long March 5DY can send people to the moon, and that's why there's a crewed version. I mean, it'll be a crewed rocket. It'll also be reusable, and it'll be using the next generation crewed spacecraft, the NGCS, which is a new, that's semi-operational now, sort of China's equivalent of Orion, that will be launched, that was already launched for the first time in 2020. And that can host up to, I think, 6 astronauts when it's sent to LEO, 6 or 7, and up to 3 when it's sent to, to lunar, translunar injection. And so, yes, definitely the Long March 5DY will be used for crewed lunar missions. And China's actually had announced that they plan to do crewed lunar landing, crewed lunar mission before or by 2030. And so that will most definitely be using the Long March 5DY. And the China's equivalent of Orion, the NGCS, for that, the Long March 9 won't be there in time for sure. Jay Wong saying, merci beaucoup, Jean, à bientôt. Well, thank you so much, Jay Wong, answering me in French, which is, of course, my native language. What other questions are there? Lee asks, vous êtes français? Yes, I am. Watching from Brazil. Hey there. Wow, you got up pretty early. Checking out some of the other questions. 1 minute Chinese, please. We want to know your Mandarin level. 可以，我会说中文啊，只是因为这是 YouTube， 所以我就用英文跟观众交流啊。但是我会说中文，所以这是我这些中国航天的讯息是从中国的这些媒体去取得这些讯息的。Okay, so that's for the Mandarin. Some people wanted a demo. There we go. It's not my native language, but I've spent quite some time in China. I've been learning it for a while, and so there we go. Let's see if there are any other questions. Okay. Okay, guys, I think the stream's been going on now for 2 hours and a half. I'm going to stop here. A bit tired. I think it's around 9:30 in France. I'm going to have a nap. Thank you very much for everyone who's joined the live stream. I see that we still have 600 viewers. That's pretty crazy. Basically almost 1 hour after the launch of Mengtian. So we should be getting updates from what's going on with Mengtian, the whole docking process. Do stay tuned. I mean, there are some great Twitter posts that are going to follow up, like great people like Andrew Jones, Seger Yu, CN Spaceflight. So great people who will provide you updates. I don't post that much on Twitter. I know I should. But that's how you can, sort of follow what's going on. And obviously for the Chinese-speaking people, you can follow what's going on Weibo. There are great channels like, Philippe, Bonnie7, people like that. All right. Thank you so much. Thank you so much for watching. And I will see you in the next episode. Goodbye.